Here are your notes on acceleration, and these are going to go on the acceleration tab in your motion foldable, and we'll also add in our last two graphs as well. So acceleration is how fast or what rate the velocity changes. Our units are meters per second or meters per second squared, so you can square that at the end, or kilometers per hour per second. Our formula is acceleration equals velocity final velocity, minus initial velocity over time. How we shorten that is we just say velocity final minus velocity initial over time. So that little subscript f and that little subscript I both equal here's final and here's initial. So here's a great shorthand way to write that. This absolutely has a power triangle for it. So our acceleration equals the change in velocity, which is essentially this upper part right here, velocity final minus velocity initial over time. So great way to use this power triangle. So an example, go ahead and write your example problem down. A car takes 2 seconds from resting to reach 80 kilometers per hour. What is the car's acceleration? So do note, on many acceleration problems, it's going to seem like you don't have enough information to actually solve. And so in this case, we're solving for acceleration, and so that's our variable here. So you need final minus initial on your velocity over time. So we have our time here, which is 2 seconds, and you're probably going to think we only have one velocity. But if it's from resting, that means that that resting velocity is 0. And so kind of remember, if you're starting to feel a little bit stuck on these, that if it's saying it's from resting or it's at the end or at the start, that you could have a 0 kilometers per hour as your initial or final velocity. In this case, 0 is my initial velocity because it's from the resting point to reach 80. And so initial is that second one right there. So it's 80 minus 0 over 2, which gives us our 40 kilometers per hour per second. And so how you work those variables out, it's kilometers per hour per second. Notice none of these cross each other out. And when we're talking about acceleration, they don't have to cross each other out because it's a derived unit of kilometers per hour per second, because we're dealing with velocity over time. And so our velocity has to be this derived unit of distance over time and then another over time. So hopefully that makes sense. If not, certainly ask some questions there. So acceleration can be a change in direction, a speeding up, a positive acceleration. So you can have a positive number here at the end. You can also have a negative number here at the end. It depends on how your velocities line up. And so slowing down can be a negative acceleration, and you might also see that called a deceleration. All right, so this graph right here, I want you to add in. So you're going to have velocity and time. Anytime you have time as a variable, it's always going to be on your x-axis. So time is your x-axis here, and velocity is your y-axis. Your title of this graph is just acceleration curve, and so it's just showing you steadily going upwards on that acceleration curve. And this is just a little bit larger so that you can see it a little bit easier on your video. So our other graph that I want you to add in is also, we're going to title it an acceleration curve, but it looks a little bit different than this graph over here because there's a positive acceleration. There's an opportunity here for 0 acceleration, meaning it's not moving, right? There's no change in the velocity. And then here is a negative acceleration. We might also call that a deceleration. So when you are done with all of your graphs, your final page of your motion foldable should look like this, where you have your average speed here, your information about whether it's a constant speed and not moving, and then your acceleration curves. So those will be helpful for you to go back and reference when you're doing your practice problems. All right, so this is the video that you just watched. You clicked on this link right here, and so you're going to go through and work on those practice problems, and there will be a key. I'll key it in right here and type that in there. Didn't have the key made before I made the video, so my apologies, but that will be up. And so you're going to have the key right there. If you get stuck on this section right here, you might go back to look at the graph video when you did your graphing from before, when it was the motion and speed graphing with the distances. So if you have questions on that, you might go reference that again, or certainly hop onto a Google Meet call or email your teacher to ask those questions. All right, good luck.